Good everyone, my name is Graphics. If you look at the front of the screen, you will see a circuit, and this circuit has 6 elements. 5 of the elements in the circuit are passive elements, while the remaining one is the active element. And we know the element is the building block in a circuit. We call those 5 elements passive because they are the one consuming energy in that circuit. And they are the resistors you can see in the circuit, which have resistances of 6 ohm, 4 ohm, 3 ohm, 2 ohm, and 5 ohm respectively. We call the remaining one active because they are the one producing energy in terms of electric current into the circuit, and that is the 24 volts that we can see in our circuit. Now we are told to what? Use the Thevenin theorem to analyze this circuit, right? Why investigating the what? The 2 ohm resistors that is placed in this circuit. One thing you need to know in your mind is that every resistor you see in a circuit is a load, right? And any of the load, emphasis can be laid upon. So if I want to use the 6 ohm resistor, I'll be told to investigate it. You can use the 3 ohm, you can use the 4 ohm, you can use the 5 ohm, whatever resistor you are using, depending on what your lecturer or what your supervisor or what your teacher has instructed you to do. But for this particular question, we'll be investigating the 2 ohm resistor, right, in this circuit. Now, before we can analyze this given circuit, we need to understand what Thevenin theorem is. We need to know what we're actually dealing with here. Now, the Thevenin theorem states that in a linear and bilateral network of sources and resistances, impedances can be replaced by a single source in series with a single resistance, where the single source is the Thevenin voltage and the single resistance is the Thevenin resistance looking inward from the terminal. To cut the long story short, what this is telling us mathematically is that the Thevenin voltage is equals to the current flowing through the investigating resistor, which we will call the I sub L, and the resistances, which is in series, the resistances, the Thevenin resistance, and what? The arrow load. The arrow load is the resistance or the resistor that we are what investigating. So this is what the entire statement is making us understand, and it's still linked to what? To Ohm's law, because in Ohm's law we say V is equal to I arrow, and the V here is what you can see as Thevenin voltage. The I here you see is the IL flowing through the investigating resistor, and the arrow equivalent is the two resistances, which is the Thevenin resistance and the arrow load, right, which are in series. That's what we have here. So I'll term it my equation 1. Now the reason why I'm writing out this particular formula here is to give us a blueprint or a path that which we'll follow to reduce our what? Our confusion, to enhance our focus, right? But before we start, I would like to label this circuit in order to enhance our understanding. Are we there? So I will say this point is my point A, my point B, my point C, my point D, my point E, my point F, G, and H respectively. So we start. What's the first thing we have in our formula here? VTH. So we say calculating for Thevenin voltage. That's the first thing we're looking for. Calculating for what? Thevenin voltage. And when you are calculating for Thevenin voltage, it means that you are going to remove the resistance that you are focusing on. You're going to remove the resistor you are focusing on. You're going to remove the resistor in which focus is laid upon, right? And that is the 2 ohm resistor here. So when you remove it, you will open circuit that part to show that what? You already removed the resistor that is there. And that will be nothing other than what? Just a terminal. So I'll call that my terminal VTH, which is my Thevenin voltage. Are we together? Now, since we've done that, we want to get Thevenin voltage. How are we going to get that? Now listen carefully. At node C, there will be a split, meaning that the current that will be flowing through the 5 ohm resistor will not be the same current that will be flowing through the 2 ohm resistor. That means the current going through the part CF will not be the same current going through the part CD. Because of that, we say these two parts are in what? In parallel. That is, part CF and part CD are what? In parallel. How good? And we know in a parallel network, the voltage are the same. So now, how can I make the current, this is my 5 ohm resistor, to be a voltage? That means when current flows through a resistor, there will be a voltage drop. So that voltage drop, because of parts DE and what? CF are in parallel, we say they are the same. So my VTH will be whatever my voltage drop will be. So what I have to do here now is to look for that lucky current that will be flowing through my 5 ohm resistor. And the only way I can actually achieve that is to get what? My R equivalent. Are together? So let us calculate for the R equivalent. Now let's start. If you look from part A to H, current will continue flowing from part A to H to A, moving from the lower potential, which is the negative terminal, to the higher potential, which is the positive terminal, through A, through 6 ohm resistor, right? So that current flowing in that manner is to be my I total, or we say my I1, that flows through this 6 ohm resistor from point A to point B. And we know that point B is a node. And when I1 flow to point B, what happened? It splits into two. That's into I2 and what? I3. The I2 will be flowing through the 4 ohm resistor, and the I3 will be flowing through the 3 ohm resistor and continue flowing until it gets to another node C. Now there's a problem, because the I3 here has a tunnel vision. It has detected that what? There is an opening that VTH is occupying. So it will not flow through that point there. It will continue flowing until it will flow as a whole, I3, and flow from that point C to point D, then through the what? The 5 ohm resistor. Are we together now? So I3 will be the one flowing through what? The 5 ohm resistor. So when we get our I3, then we'll multiply it by 5. And when we multiply it by 5, we'll be having a voltage drop, which will now be what? The same as my VTH, because both of them will be in parallel. So let's move forward. Now, since I take my focus from the front here, my I1 at the front here, so it means I will start calculating for my resistance from the back. Remember how I've been telling you that. Now, the only way I can write my R equivalent, the only way is when I am taking all the resistors in that circuit as a single unit. But in this case, I'm taking them bit by bit in order to enhance our understanding. So I'll be using other representation than using my R equivalent, instead of my R equivalent. So I will use arrow sub A, because the same current that is flowing through 3 ohm is the same flowing through 5 ohm. We say 3 ohm and 5 ohm are in series. So I'm going to put that my arrow A is equal to what? 3 plus 5, and that is equal to what? 8 ohm. So I'm going to change this resistor here into what? Just one single resistor, and that is what? 8 ohm. Are we there? Now, if you notice it, I3 is still the one flowing through 8 ohm. That is as a result of what? 3 plus 5. And I2 is flowing through 4 ohm. Because of that, different current flowing through the resistors, we say both 8 and 4 are in parallel. And I will now use another representation to represent this particular resistance here. So I will say arrow B is equals to what? 4 parallel to what? 8. Because 4 and 8 are in parallel due to the two different currents flowing through them. So my arrow B will now be 4 times 8 divided by what? 4 plus 8. And that will give me 32 all over 12. And 32 over 12 will give us 2.67 ohms. Now what have I done successfully? I have merged the two resistances in parallel. They are now one, acting as a single unit, acting as a team. They are now one, right? So if I should now redraw my circuit, I'll be having this that you can see. So I1 is still the one here, now flowing through 6 from A to B, now flowing through from B to what? B to G. Now see that they are all 6 and arrow B are in what? In series, because the same current I1 is flowing through them. So I1 is the one occupying this particular circuit here. We're moving in this manner. So we say that the 6 ohm and the 2.67 ohm are in series. So now, and that is the only resistors we have in this circuit. So we'll now use our arrow equivalent, because we've taken everything as a single unit here. So my arrow equivalent will now give me 6 plus 2.67, and that'll give us 8.67 ohms. Are we together? Now, recall, since we've gotten our arrow equivalent, we want to calculate for our current now. So we say that V is equals to what? I arrow, that is Ohm's law, where V you see here is our voltage source, which is 24. The I you see here is our I total, which is saying I1. And the arrow you see here is our arrow equivalent, which is what? 8.67. Are we there? Now, if you make your I1 the subject of the formula, we say that I1 is equal to 24 over 8.67. So my I1 will now give me what? 2.77 ampere. And which is saying my R total. So we've gotten I1. This I1 is the one that split at node B, as you can see from our diagram. It's split into two different currents, I2 and I3. So we need to find the value of I2 and I3 with the help of what? A young man named current divider rule, right? So we're calculating for I2 and I3. Now what you do is this: just come to this point, you have arrow B, because you only use current divider rule when you have a parallel connection, and this is our parallel connection here. So I'll remove this arrow B, be watching, and I'll write it as I2 equals to, now the I2 is flowing through the 4 resistor. Now from this my 4 times 8, I will not write the 4 because I2 is flowing through it. I will only write the 8 divided by 4 plus 8. I'm only focusing on the one on top, the numerator, not denominator. So I write only the 4 all over what? 4 plus 8. Now, since I have removed the 4, I have to replace it with something. And what will I replace it with? I'm going to replace it with the current that divided into I2 and I3. And that is I1, which is saying my I total here. And what is the value of the I1 and I total? That is 2.77. So it will be 8 times 2.77 all over 4 plus 8. And that will give me 22.16 divided by what? By 12. Because 8 times 2.77 is 22.16. and 4 plus 8 is 12. And when you divide both of them, you'll be having 1.85 ampere. That is my I2. Now you still go back again, you do the same thing for I3. So if you're writing RB from here, you're going to replace it as I3 equals to, now where is I3 flowing through? I3 is the one flowing through the 8 ohm resistor, which is at the rate of what? The 3 and the 5 ohm that we added because of their in series. So I3 is flowing through them. So we're going to remove the 8 ohm and write only 4 divided by 4 plus 8. But because you remove the 8 ohm, you must replace it with something. And what will you replace it with? With the current that divided. And what is the current that divided? That is I1, which is equals to our I total. And that is what? 2.77 ampere. So when you do that, we'll now be having 4 times 2.77 divided by 4 plus 8. And that will give us what? 11.08 divided by what? By 12. And our I3 will now give us 0.92 ampere. So we've gotten the value for I2, we've gotten the value for I3. Now we have what we are looking for is the value of I3 because that is the current that is flowing through the 5 ohm resistor. So what we are going to do is to get the voltage drop because when current flows through a resistor, there's a voltage drop, right? So we say that according to Ohm's law, V is equals to what? IR. Now the V we're talking about is the voltage drop at the 5 ohm resistor there. The I we're talking about is the current that is flowing through the 5 ohm resistor, which is our I3. And the R we're talking about is the resistor that has a resistance of 5 ohms. And what is the value of the I3 is 0.92 multiplied by the value of the resistor that the I3 is flowing through, that is 5. And if you multiply both of them, you'll be having 4.62 volts. So our voltage drop across the 5 ohm resistor is 4.2 volts, which is the same as our Thevenin voltage because of what? Both are in parallel due to there's a split at the node C, like I explained before now, right? So the VTH equals to what? The voltage drop as a rate of the 5 ohm resistor, and that is 4.62 volts. Am I communicating? So if you are finding this video interesting and educative, please click on the like button. Also subscribe to this channel so that others can have benefit of this particular video. Now we proceed. We've gotten our VTH now. The next step, if you look at our formula at equation 1, what's the next thing there? We'll go and look for our ROTH first. Right? We'll look for what? Our ROTH. So the ROTH means the Thevenin resistance. So what we're going to do when you're looking for Thevenin resistance, you are going to still go back to the parent circuit. You remove the 2 ohm resistor. You now short circuit the 24 volt voltage source there because that is the voltage source you circuit. If it was a current source, you're going to open circuit. Are we there? So this is what you'll be having. So here's my ROTH, this opening you have here because you've removed the 2 ohm resistor. Now see what will now happen. Current will start flowing from this part here going upward. When you now get into the node C here, it splits into I2 and what? I3. Right? I2 is going towards the right, I3 is going towards the left. And this I3 will move further through the 3 ohm resistor and get to node B, then split again into I4 and I5. Right? Now, we have two sides of this circuit now. The part I2 is flowing through and the part I3 is flowing through. The part I2 is flowing through only have just one resistor. So that is the champion there. We have someone representing that particular area. Now, if you look at the left-hand side, we have more than one resistor. We have 3. So we need to get the real champion here. And the only way we can get the champion there is to bring all the resistors together. Right? So we'll be starting from the left-hand side and both from the right-hand side. But majorly from the left-hand side, because the right-hand side is already having one resistor. So we will leave that first. Then we'll go to the left-hand side. So because we're taking our point of reference is at in between them here. So what do you notice? I5 is flowing through 6 ohm, I4 is flowing through 4 ohms, making what? 6 and 4 in parallel because two different currents are flowing through them. Now I will use arrows of A. You know the reason why I'm using it? Because that is not the total resistors in that circuit. So arrows of A is giving us what? 6 parallel 4. And 6 parallel 4 means 6 times 4 divided by 6 plus 4, which will give us 24 all over 10. And our arrow A will now give us what? 2.4 ohms. Are we there? Now, once you've done that, 2.4 ohms, that's my arrow A. So we've made 6 ohm and 4 ohm to become 1, right? So what is the one they have become? That is arrow A, and the arrow A you see here is 2.4, right? Now what do you notice? I3 will be the one flowing through the 3 ohm and the 2.4, making both of them to be what? To be in series. So I will say my arrow B will now be equal to 3 plus 2.4, and that will give us what? 5.4 ohms. Now I will now make them to be 1. So my arrow B will now be the one here. That will be what? 5.4 ohms. Are we together? Having in mind that I3 is the one flowing through the 5.4 ohms, and so we have gotten our champion. The one single resistor that is representing all the resistor at the left hand side, which is 5.4, and the one single resistor that is at the right hand side, which is the 5 ohm resistor. So because I3 is flowing through the 5.4 and I2 is flowing through the 5 ohm, we say both of them are in parallel. And these are the only two resistors we have in this circuit. So we'll now use our ROTH because that's what we're looking for, just like we use our R equivalent. So the ROTH, which is the R Thevenin, will now give us 5.4 parallel to what? 5, because they're in parallel. So which means 5.4 times 5 divided by 5.4 plus 5. And when you do that, you'll be having your value to be 2.59, which is approximately 2.60 ohms. Right? So this is what we have. We've gotten our ROTH. So from our formula here, we've gotten ROTH, we've gotten VTH. Now the next thing is what we've gotten ROL. ROL is the resistor we're investigating, and that is 2 ohms. So when we put all this into our formula, we say that my VTH, which is giving us what? The VTH, which is giving us what we calculated for here, and that is 4.62, equals to the IL, which we don't know, into bracket the ROTH, which is giving us what? The 2.6, plus the RL, which is the investigating resistor, which is 2, right? And when we add two of them, we'll now be having my 4.62 equals to IL multiplied by what? 4.6. Are we together? So if you make your IL such as the formula, IL will now give me 4.62 divided by what? 4.6. And that will give me 1.00 ampere, which is 1 ampere here. That is my IL. So in a nutshell, if I should draw the Thevenin equivalent circuit, this is what I will be having. The VTH, according to the law, that says that what? A single source is called the VTH, and that VTH we've gotten here to be what? 4.62, right? Plus, with two resistances in series, that is one of the resistances, the arrow Thevenin, which is 2.6, in series with the arrow load, which is the 2 ohms. And the load, the current here flowing to the arrow L is the IL, and that is what? The 1 ampere. So this is how you can represent it in your given circuit. So this is our Thevenin equivalent circuit that we're talking about here. So if you are now told to calculate for the power of this given resistor here, the 2 ohm, we know that our power is equal to what? I square R, and we know our I is the IL, which is given as 1. So 1 square is 1, and we know that the RL is the 2 ohm resistor here, and 1 times 2 is 2. So the power will now give us 2 watts. So that is what? The 2 watts. That is the power that can actually get to that resistor that we have there. So if you have found this video helpful, please don't forget to like this video, and don't forget to also subscribe to this channel and share the video so that others that are in need will have benefit of it. You always remain my number one sponsor, which are my fans. God bless you all. Bye bye.